everybody, and welcome to this video on probability. In this video, we're having a look at counting with identical objects. So sometimes the things that we are counting are considered the same, and that will affect the way that it is counted. So let us first have a look at an example of this so you can understand what I am talking about. If we have the word see, and it's S-E-E, you can see the E's are repeated, they are considered identical objects. Now, if we count the number of ways that C is rearranged using the method we spoke about earlier, we'll get 3 factorial, which is 6 ways. The reason why we get 6 ways is because the 2 E's are considered to be different from each other. So it considers the blue E, and I've just highlighted it, the blue E and the green E being in different positions as different words. But you know from the way that letters are that these two, for example, are the same word. So if you have identical objects, you can't just say that it is 3 times 2 times 1 to arrange it, which is 3 factorial. You have to account for the fact that some objects are identical. So what we have is that the 2 E's are the same. So what we can then do is we only have 3 unique answers. So it's either C, E, S, E, or E, E, S. So those are the 3 unique ones. And then how do we then count for them is we divide by the number of repetitions of the identical item. So in this case, we calculate the numerator by arranging all 3 letters, and then we divide by the number of repetitions of identical letters. So this here will then become 3 factorial, and E is repeated twice. So that means we're going to put 2 factorial in the formula, and then what we're going to have is then 3, which is then the number of unique combinations of the words S-E-E. So please remember this for any time that you have identical objects or objects that are considered the same. Let us have a look at an exercise. So it says, how many ways are there to arrange the following letters? So the first one is speed. Speed is a 5-letter word. So how many ways are there to arrange these 5 words? So 5, 4, 3, 2. So using the counting principle, for the first letter, we have 5 options. And assuming we're not repeating letters, for the second one, we have 4 options. For the third one, we have 3 options. For the next one, we have 2 options. And lastly, we have 1 option. So the number of ways of arranging the word speed is then 5 factorial. But then what we note is that there are repetitions of the letter E. So we have to then divide by the number of repetitions factorial, which is 2 factorial. So when we then simplify this, we're going to get that it's equal to 5 times 4 times 3, which is 60 different ways of arranging the word speed. Let us have a look at the next word. So magician. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So the number of ways of arranging those 8 letters will be 8 factorial if we're going to use the counting principle without repetitions. But now we have repetitions, but we don't only have 1 repetition, we have more than 1. So we have that A is repeated twice, and we have that I is repeated twice. So we have 2 repetitions. So how will we deal with this? We'll divide by 2 factorial, and that's because there's 2 A's. And then we'll also divide by another 2 factorial because there are 2 I's. So then this here then becomes, and you can type it into your calculator if you would like, it's 8 factorial divided by 2 factorial times 2 factorial, which then the total number of observations is 10,080. Okay, so the last word is this word engineering. It's a long word. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So there's how many ways of arranging that? 11 factorial ways of arranging the 11 letters. And then what we have are repetitions. We have E repeating. So we have 1 E, 2 E's, 3 E's. We have N repeating. So we have 1 N, 2 N, 3 N's. We have the I repeating. Actually, we have the G repeating first. So we have 1 G over there and 2 G's over another G over there. And again, we have I repeating. So there's lots of repetitions in this word. The only letter that's not repeating is the R. So how do we then account for it? Is that we divide by the number of repetitions. So let's do the E's. So there are 1, 2, 3 E's. So we're going to divide by 3 factorial, and that's accounting for the repetitions in the E. Then there are 1, 2, 3 N's. So we'll divide by 3 factorial, and that is accounting for the repetition in the N's. Then there are 2 G's. So we're going to divide by 2 factorial, which is accounting for the repetitions in the G. And then we're going to divide by another 2 factorial, accounting for the repetitions in the I's. So just to reiterate, first we arrange the whole word. And then we divide by the number of repetitions. Okay, so then you can calculate this by expanding it or typing it into your calculator, whatever you feel more comfortable with. It doesn't matter as long as you have this, the values correct. So if we can then calculate it, the number of ways of arranging the word engineering is 277,200. Very important, please make sure that you go over this video and you understand how to deal with identical objects. And every time you have identical objects, then you account for them like this. Thank you for watching. Please subscribe and see you in the next video. Thank you.